Our next speaker has brought with him a little bit of sun from California. It's peeking through the clouds now. I hope it stays with us. Peter Norvig is a Distinguished Education Fellow at Stanford's Human-Centered AI Institute and a researcher at Google Inc., having previously directed Google's core search algorithms and Google's research group. He was head of NASA's Ames Computational Sciences Division. He has taught at the University of Southern California, Stanford University, and the University of California at Berkeley, led tremendously successful AI classes online, and his many publications, including Artificial Intelligence, A Modern Approach, is a leading textbook in the field. His talk will be on human-centered AI. Welcome to the stage, Peter Norvig.
Thank you. So the talk has a question mark in it, and I'm going to be asking a lot of questions, so I hope that's okay with you. Come on, green button, go. So first question I want to have is, why do we even have the field of AI? It formed around 1956, and at that time, we had all these other fields as well. And they were making contributions in these important domains, and they all pretty much had a similar approach of saying, our fields are designed to solve problems by maximizing expected utility to make rational decisions. And that's also what AI does, but why do we need a separate field? And I think the reason is AI wanted to solve different types of problems using these same approaches, and the other fields were resistant. So AI came along and said, I want to do some inference over 1 million pieces of data. Hey, statistics, that's your field, right? And statistics says, whoa, wait a minute, 1 million? Nah, what we're really good for is if you want to say which drug is better and you have 30 people in one trial and 30 people in the other, we can tell you if it's a significant difference. We don't want to deal with that other stuff. So AI said, okay, we'll take our toys with us, we'll go form our own field. And that's why we are here, where we are today. And another thing I always try to figure out is, well, software engineering is building systems that do the right thing, but so is AI. So what's the difference? And I think the main difference is, where do the problems come from? So for software engineering, the problem is complexity. You have an operating system with 1 million lines of code, and every line has to be there because there's some special case you have to deal with. But in AI, yeah, you got some complexity, but the main enemy is uncertainty, that you're addressing these problems that maybe don't have a definitive answer, right? So you're saying, explain quantum physics with rap lyrics. There is no yes or no correct answer for that. It's a matter of degree, and there's uncertainty about it, and that's where AI shines. And then I'm going to talk about human-centered AI, where we do the AI thing, and the emphasis is to do it for everyone, not just to do it for one user, but to do it fairly across the board. Now, I was here in Boston about 5 years ago, and I had this interaction with my phone that led to an epiphany for me. So this thing popped up, didn't look exactly like that, but basically it was really helpful, and it was time to go to Logan. And if I wanted, I could stop at Dunkin'. So I knew I was in Boston. So that was great, but that wasn't the full story, because then it went and ruined it all by saying time of travel, 23 minutes by bicycle. And I said, okay, I'm a Google employee, this is a Google product, there's a bug, I better file a bug report. And I say, there's a drop-down list that says, whose fault is it? And I start going through, and they said, well, they did a great job parsing the email from Hertz. They did a great job putting in a calendar entry and displaying the alert based on the calendar entry at exactly the right time, and adding a map with exactly the right destination. So maybe the part was predicting when the user should use a bike and when they shouldn't. But on one hand, they did a pretty good job, because I commuted to work by bike every day, and it was about the same amount of distance. So that part was right. There was just this one thing that you can't really commute by bike when you've got a rental car to return. And I said, should I file a bug saying, They should put in a line of code that says, if the title of the event is returned rental car, then don't recommend going by bike. I guess you could put that in, but if you're going to put that line of code in, now it opens it up to, there's like 1 million lines of code you're going to have to put in that are similar to that. And eventually I just decided, no, this is not a bug. This is out of scope. And if I'm writing traditional software, I can't solve that problem. But if I'm writing AI, then it is within scope. And so that's the difference between traditional software and AI. And can AI solve it? Well, turns out it's not all that easy. So this is ChatGPT 3.5. It's had adaptation to be safe. And so when you ask it, it gives all these hedges, right? Riding a bike depends on distance, time, weather. No, they got it wrong. And it wasn't until, and same thing happened with Bard earlier, but this last month there was an update to Bard, and finally it just says no. And then it gets some good reasons, and then there's a little bit of hedging. It probably should have stopped a little bit earlier. But finally, 5 years later, we solved this problem. So that's the difference between software and AI. Now let's get to this idea of human-centered AI. So we want AI that involves early engagement in multidisciplinary teams, right? So it's not just you define a problem, you throw it over to the engineers, and they build something. It's upfront. You bring in the ethicists, the lawyers, the sociologists, and so on. You bring in multicultural teams. You consider all the users who are going to be. And you do that as part of the design rather than as an afterthought. And you consider the impact, benefits, and harms to all the people involved. And we'll talk about that in a bit. And you give appropriate control to the humans. It's not just, I'm going to automate everything for you, but I'm going to make you feel comfortable. And in general, you want something that augments rather than replaces the humans. And finally, it's really important that it's transparent, that you understand what it's doing, and has all these good abilities of being accountable, secure, privacy preserving, and so on, and fair, right? Which we had that before, that you want to help all the people, and you want to do that in a fair way. And that kind of changes the way that you look at how you define the problem. So a big part of that is looking at the multiple constituencies. And if I was just doing kind of a traditional approach and I'd say, okay, I want a self-driving car, there's a user who we used to call the driver, now we'll call him the passenger, and we have to serve them, right? We need to get them to their destination safely and maybe give them a little UI to deal with, and if they're happy, then we're done. But human-centered AI says, yes, you definitely have to do that. But in addition, you have to consider the other stakeholders. So there's going to be pedestrians, there's going to be other drivers of other cars, and they're part of the system. And if you don't make them happy, you haven't built the right thing. And then finally, there's the effect on society as a whole. So how is this going to affect urban sprawl? How is it going to affect traffic patterns? What about unemployment of taxi drivers and truck drivers? That's all part of the problem, and a solution has to deal with all of them. Another example is, say you're doing a decision support system for a judge, and we'll talk about that a bit later. Traditionally, you'd say, well, the user is the judge, and so they've got their laptop there, and if there's a nice display with charts and graphs and so on that tells you all the information you need to know about the case, now you've done your job. But in human-centered, we say, let's look at the other stakeholders. So are you doing a good job for the defendant in the case? Are you doing a good job for the victims of various crimes? What about the families of all these people? What about the effect on society of mass incarceration and bias and unfairness and so on? So you have to take a broader approach to making these solutions, and when you do, they'll be better accepted, right? So if you just focus on the one user, you're apt to run into resentment from other people saying, how come they've got that? What about me? And so taking this broader point of view makes your whole approach more acceptable. Okay, so why do I care about human-centered approaching? So one is that addresses the real goals of we want to help people. And too many times when you have an approach that's focused too narrowly just on machine learning, you have things like, well, I maximized accuracy, But maximizing accuracy is an internal measure, but it doesn't really measure, am I successful or not? So this helps us actually be successful. It helps build trust and consensus with your users. So even if you have a system that's performing great, if the users don't trust it, they're not going to use it. Well, one thing is that it's kind of an undeveloped area, and thus it's easier to make progress because it's less crowded over here. So let's sit over here. And then finally, just because it works, that you get good results from it, so let's keep doing that. Now, so this is the Society of Automotive Engineers. They've defined this 6 levels. They call it 1 to 5, but of course there's level 0, which is no automation. So this is the amount of automation for self-driving cars. And we're mostly at about 2 now. And I think Mercedes is the only ones that have been certified at level 3. But look at this schematic. The user starts to disappear as we get to full automation. Do you want to disappear as a result of having that car? No, I don't think so. So Ben Schneiderman, who was visiting here just yesterday, came up with this 2-dimensional approach, saying, yes, you can vary the amount of automation along this dimension, but you don't want to trade off to say the more automation, the less control. Let's think of that as a separate dimension. And you can be at any place in that 2-dimensional space. And so one example is a camera. Maybe I want a camera with a lot of automation, so I don't have to worry about it. I just click the button, a good picture comes out. But maybe I also want control. I want to say, you know what, it'd be really cool to have a long exposure with some motion blur. So I want the control to be able to do that. I don't want to give up completely to automation and make that creative choice. I want to have that creative choice. So there's these 2 dimensions according to Ben's framework. I think it's a really great framework. But if we go from 1 to 2, maybe we could keep going, right? So Ben's got the automation and the control. I think choice is a little bit different than control, right? So control is saying, I want to be able to press that button. But choice is saying, I still want the automation to press the buttons, but I want to give it some advice, right? So I'm in the self-driving car. I don't want to say, turn in this direction, but I want to say, you know what, let's take the scenic route rather than the fastest route. And so I'm giving advice rather than taking actions. We can have a dimension of transparency. How much does the machine make you aware of the context into what it's doing? Sometimes that's really important. Other times you don't care, and you're happy for the machine to make its own decisions. And certainty. You want the machine to tell you when it's really sure, and we heard about that earlier today, and when it doesn't know. And then the speed. How fast is it making decisions? Sometimes you want a human in the loop. Sometimes it's going so fast that you can't do that at all, and you just want to be standing by on the outside. How does that cycle work? So I think all of these are important to look at. Okay, so what is machine learning? Next question. Well, I think of it as saying you got an algorithm, you throw in some data, you've got some objective you try to maximize, and in processing that data to maximize the objective, you set the parameters of the algorithm. And as mentioned, I wrote this textbook. Here's 3 out of the 4 editions. And in 1995, we said, AI is just part of computer science. Computer science is about algorithm. We're going to have a book full of cool algorithms. In 2003, we said, we still got the algorithms, but the book got fatter because we had another approach that said, we're just getting into this era of big data. And maybe for a lot of problems, don't worry so much about the algorithm, but concentrate on how to get better data. And we tried to describe how to do that. In 2020, we said, yeah, we still got the algorithms and the data, but you're going to download them from GitHub anyways. But what's really important is saying, what is it that you're trying to maximize? What is it? What's your objective? What is the machine learning trying to figure out? And I'm embarrassed to say, in 1995, we kind of had the approach of saying, well, your professor or your boss is going to tell you what to maximize, and then we're going to show you how to do it. That was the wrong approach, right? Really, we got to say, this is the hard part. It's figuring out what you're trying to do. Once you've done that, we've got all this machinery, and the rest is easy, right? So what tooling do we have to make those choices? Well, for algorithms, it's fantastic, right? It's so much harder now to put a bug into a line of code than it used to be. So we've got these great software development environments. For data, well, you know, we started with SQL about 40 years ago. We've got some tools, but one of my hobbies is keeping track of when a big cloud provider has an outage or something. And it's hardly ever because of the code. It's not because somebody wrote a wrong if statement. It's almost always in the data. There's a configuration file, and they had the wrong host name, and then that propagated and so on. And I see people shaking their heads, right? So you've had this problems too. And the reason is we don't have strong typing and so on for data, and we don't have the tools to debug that as well. So I think there's a great opportunity there to do a better job. And then in terms of the objectives, we're even worse off. We don't really have any mature tools to say, what is it that you really want? What should you be maximizing? If you try to maximize this, what's going to happen? I know at Google, we learned lots of lessons. We thought we were observing the world, which is what machine learning traditionally does. And then we figured out, no, we're actors in this game theoretic world. And when we make a change, say, to our ranking algorithm, all the spammers respond, and they make a change. And so we have to sort of think ahead. Well, if we optimize this, how are they going to respond? Uh-oh, that was a bad thing to optimize because they have a good mood. So we're going to have to come up with something else. And I think the field as a whole could really concentrate on better tools for defining what it is that you want. Okay, so what could go wrong with this approach? And I want to have this case study of this compass system, which was for helping a judge doing recidivism prediction. Is this defendant going to recommit a crime? Help you decide if they get parole or if they get bail. And ProRepublica, one of the first examples of data journalism, came in and says, look, we looked at the data, and it turns out when your system errs, there's always false positives and false negatives. You add those up, it harms black defendants twice as much as white defendants. So you're biased, and you have to fix that. Seemed like a super compelling case. But North Point, the creators of the system, had a different response. They said, that's not what we were trying to optimize. We were trying to make our system well calibrated, which means if you get a score of 6, you're 60% likely to commit a crime. And look, we've achieved that across the board, whether you're black or white. The scores calibrate well. 6 means you're 60% regardless of your race or gender and other factors that they control for. So they said, we got it right, don't bother us. John Kleinberg at Cornell came along and said, okay, the problem is there's 2 different metrics. They're arguing over which one's best. I'm going to invent a metric that optimizes both of them at once. But he quickly found out that that's mathematically impossible, that there's always a trade-off between the 2. If you make one better, you necessarily make the other one worse. And so the resolution of that is saying it's not a mathematical question. It's not a software question. It's not an AI question. It's a societal values question. We have to decide, what do we think is fair? What is the metrics that represent our values, that represent our sense of fairness? And neither of these sides can do that. We have to do that as a society. William Blackstone, this 18th century jurist from England, says, it's better that 10 guilty persons escape than 1 innocent suffer, right? So he was taking a stand of how he wants to weigh off the false negatives versus false positives. I'm not sure if he really meant numerically that 10 was the exact optimal value of that parameter, that 9, that's okay, 11, no, that's bad. I'm not sure if he meant that, but he definitely meant that it's more important to err on one side than another. And so maybe we want to take that as a societal value. So those are questions to answer, but I want to also say, we got into this case study, there's lots of other things you can look at. So one reason they didn't do well was this failure to bring in multidisciplinary teams up front, right? Outside criticism came in and said, look, you did all this work over years, maybe your underlying assumptions were wrong. And they could have avoided that by having enough stakeholders in at the beginning and saying, look, there's other ways to look at this. You found one way to look at it, but here are other ways. And then saying, uh-oh, we better deal with that up front. They wouldn't have had the problem. Another problem is there's no access to ground truth, right? So they're trying to say, well, what we're trying to do is decide if you're going to commit a crime. There is no data on who commits crime. Like in most cases, there's only proxy data. So there's proxy data of who gets arrested, and of those people that are arrested, there's proxy data of who gets convicted. But there can be bias in both of those steps, right? People who commit crimes are not arrested. People that are arrested are convicted at different rates, and bias can come in there. And then this emphasis on this internal metric of accuracy rather than something that's more relevant to the stakeholders, right? So my feeling is that ProPublica is right, that looking at the harm to people, that's really important. And looking at this internal metric of, is it 60% or so on, that's relevant if you're a machine learning engineer, but it's not really relevant to society. Okay, and I've worked some with Code for America, and they have this motto that I like saying, justice is getting the implementation right. So what they mean by that is, sometimes we have justice. We have laws that say, for example, if you have an arrest record, you can get it expunged from your record after a certain amount of time, and that's great. But the implementation is so lousy. There's so many forms you have to fill out, and you have to go to this office between 2 and 3 p.m. and fill it out. Nobody gets it done. And so what they say is, well, maybe we can automate that. Maybe we can make that process easier. Maybe we can use AI to automatically recognize who's eligible to get that service. So just making the service exist is not enough until you've done that implementation to make it easy to use and you get it out there into the world. Okay, so why do we want these multidisciplinary and multicultural teams? So you identify more use cases. Different users may use the product in different ways. You expose more threat surfaces. Different users may attack the product in different ways. It allows you to generalize more. You discover holes in the data coverage, right? So we thought we had data that covers everybody. Oops, now we look at the subpopulation. We don't have any data from them. You can synthesize different values. So there's a paper just this week from Anthropic. They have this idea of constitutional AI, that you tell an AI what to do rather than by just showing it examples, by giving it a constitution, saying, thou shalt not steal, thou shalt not create falsehoods, and so on. And they had an interesting experiment of saying, well, we don't want our Anthropic engineers to do that. We want the public to all say what they think our system should do, and then we'll synthesize that. So I think that's an interesting approach. And getting that diversity, I think, is important. And if you can do that, you better align with your technical, business, and social goals. Now, so one more question I wanted to ask. What about adversarial attacks? So this was a famous paper that says, here's this picture. An AI vision system can say this is Panda. Now you introspect on the model itself and you say, what's the smallest change I could get that would move it over the decision boundary from Panda to something else? And you're adding 0.07, so less than 0.1% of change to this picture. And then you get this picture and the system calls it a given. So people looked at that and said, whoa, we can't trust these systems because they make these terrible mistakes. It's obvious. That looks like a Panda. It looks like the exact same picture. So why can we trust these systems? And the scary part is that you can do this when you introspect internally on exactly what the parameters are, but the same attack tends to work for other models that you haven't had internal access to. So that's scary. But on the other hand, are humans immune to these attacks? No, right? We're just as bad. We're just bad in different ways. How many people think this is made out of straight lines? Nobody. We cannot see that they're made out of straight lines, but if I go up here, yeah, they are. It just looks that way because of the way our visual system is built. How many people are thinking, I really need some more insurance now? Oh, wait a minute. That gecko, he's so cute. And this phrase, 15 minutes, 50% or more, that's so catchy. Shut up and take my money, right? So in fact, the whole advertising industry is an adversarial attack on the quirks of our minds. And we're vulnerable to that. So maybe we can have a partnership where we have some human-centered defenses against these adversarial attacks. So let me stop there and open it up for discussion.
We have time for maybe one or two questions. I do see a hand right there.
Right here. I love this, Peter. You talked about, I really like the fact that you pointed out that there's a trade-off between different metrics you use for different stakeholders. I find that in a lot of the work that we do, that all academics do and people in industry do, is to measure metrics which are easy to measure rather than the right things to measure. Now, I don't see an easy solution for when you have conflicting requirements or end objectives, how to get metrics which are sensible to all of them. Do you have any thoughts about that?
I mean, I don't know if I have a general case, right? I think you got to look at each example and say, what data do I have available? What other data could I generate? How is this likely to go wrong? I mentioned this idea of if you're in a game theoretic situation, you do something, the world may change because there are competitors. Goodhart's law says that in general, every time you start optimizing for something, you're vulnerable to optimizing too much just for the metric rather than for the thing you really want, right? Because the metrics are always proxies. They're never really the right thing. So I don't have an answer in general, but I guess you want to get closer to the ground truth rather than a reflection. Think about spending more time to do that. Think about how you can gather data that you don't have available to you. And so a lot of companies do things like they build an AI and they rely on their users to explicitly or implicitly give them feedback through clicks or whatever and build the data that they didn't have, right? So at Google, we wanted to do speech recognition. We didn't have enough examples of speech, and so we built a free system to do directory assistance. This was back in the day when you actually called up on your phone and said, what's the number for Joe's Diner? And we built a free system for that, and so we got lots of examples of speech that we otherwise wouldn't have had. And so constructing the data you want is often an approach. And then I guess also think about zeroing in from multiple directions, right? If there isn't one metric that will give you the right thing, say, are there 4 or 5 different ones that I can combine?
Thank you so much, Peter. So I've been working in tech and AI for a little while now, and this just human-centered AI gives me hope. And tomorrow I'm actually working with an agency in Hollywood, and after the writer's strike, a lot of people realized they just can't wait anymore. And after we organized the webinar, hundreds of people signed up. So what are some of the things you would recommend to people who have no prior experience, really fearful of AI in general? How to help them get started?
Yeah, I guess just start playing with it, right? So I think a lot of fear comes from unfamiliarity. So start using it, and for things like the writers, I guess they're worried of what their future is. Are they going to be replaced? And I think in most cases, including this one, it's not going to be that an AI is going to replace you. It's that a person using AI tools is going to do better than a person without the AI tools. So I think they should be aware of that. So I think, for the strike in particular, part of was around AI and new technology and so on. But I think more of it was around sort of the power dynamics and, the studios and say the record companies took advantage of a disruption to shift things in their direction, right? So, like, I guess I know more about the music industry, and the artists were better off when they were selling pieces of brown plastic. And then when we went to selling downloads, somehow the world shifted out from underneath them and they got left saying, well, wait a minute, we got a lousy deal. We're getting a lot less now. And that didn't have to happen. I think that wasn't really a technology shift. That was more a power dynamics shift. And so, but I guess one thing is encouraging is saying unionizing does seem to help, that you get closer to what you want if you can share some of that power, and unions are a good way to do it.
And we do have a question that has come in virtually. We do have two, but we'll go ahead and name one, and I'll share the other one afterwards. It comes from Michael Krigsman, industry analyst and publisher of CXO Talk. Peter, if you were to construct a 10-point agenda for discussing responsible AI, what would the key points be?
Oh, boy.
Doesn't need 10, but...
Geez, that sounds like a question for ChatGPT. All right, it's probably better at coming up with 10 points off the top of its head than I am.
That's an unfair ask.
So I don't know. Go back to what I said. I think I had 10 points in there. So we can try to share the slides, and you can find them in there.
Thank you so much.